Okay, let's get right into it. So, you've got one of the smartest AIs in the world. You hook it up to some powerful new tool like a physics simulator or a complex world model, and you're expecting fireworks, right? But instead, you get nothing, just failure. It's a hugely frustrating problem, and today we're going to break down exactly why it happens and then get to the really exciting part, a groundbreaking new fix. It really is a paradox, isn't it? It just doesn't make any sense. You give a smart system a better tool, and it should get smarter, not dumber. But that is exactly what's happening in the real world. So what is going on under the hood of these massive models?
All right, first things first, let's get this out of the way. It's not you. So if you've been pulling your hair out trying to connect a world model, maybe using something like the Model Context Protocol, MCP, you can take a deep breath. This isn't about a bug in your code. Nope, it's way deeper than that. We're talking about a fundamental design flaw in the AI's mind.
So before we can even talk about a cure, we have to get the diagnosis right. And what researchers found is, well, it sounds surprisingly human. It's like the AI is suffering from a kind of cognitive disorder, one that's all about a total lack of self-awareness.
The fancy term for this is metacognitive overconfidence. But what does that actually mean? Well, to put it simply, the AI has no idea what it doesn't know. It's so confident, so sure of itself and its own training data that it would rather take a wild guess than admit it needs help and just use the powerful tool you put right in front of it. Now, this isn't happening with all tools. That's the key thing to get. If you give an AI a calculator, what we call a deterministic tool where there's always one right answer, it's fine. It does okay. But the moment you hand it a physics simulator, a probabilistic tool that spits out messy, complex, uncertain data, the whole thing just falls apart. It absolutely cannot deal with that kind of ambiguity. And here's the part that's just wild, because it's completely backward from what you'd expect. You'd think, hey, let's just throw a bigger model at it, right? But the research shows the exact opposite. As these models get bigger and more capable, they actually get worse at this. They become, and this is the word the researchers use, more arrogant.
Okay, so that's the diagnosis. But talk is cheap, right? Let's look at the actual data, the lab results. And I'm telling you, what they found is pretty shocking. It really shows just how deep this problem goes.
Get this. In some of the tests, when researchers gave a large language model a super helpful world model, it only chose to actually use it less than 1% of the time. Yep, you heard that right. Less than 1%. More than 99 times out of 100, it basically said, nah, I got this, and went with its own, often wrong internal guess.
But wait, it gets even crazier. So the researchers thought, all right, fine. What if we don't give it a choice? What if we force it to use the tool? And the result? Its performance tanked. It dropped by a staggering 9.2 percentage points. Forcing the AI to use a helpful tool made it worse at the job. It literally made it dumber. So why? Why on earth would that happen? Well, it boils down to three big failure points. First, it just can't integrate the data. It sees all this rich information from the simulation, and its brain just registers it as static, meaningless noise. Second, it gets stuck in these action loops. If the tool gives it an answer that contradicts what it thinks it knows, it just freezes and does the same wrong thing over and over and over again. And finally, there's just a deep structural weakness. It has no way to take new information and use it to update its plan. So let's be super clear about where the breakdown is happening. It's not in the initial planning phase. The AI is actually pretty good at coming up with a plan. The problem, the total system failure, happens the moment it gets results back from the tool. It just cannot interpret what it's seeing. It literally sees the right answer, but has no clue what to do with it. Okay, that's a lot of doom and gloom. We've got an overconfident AI that gets dumber with better tools. So what's the fix? Well, a really brilliant solution came out of Tsinghai University. It's a framework called Atlas. And honestly, it's a complete shift in how we should be thinking about all of this. What Atlas does is it basically gives the AI a two-system brain, kind of like how our own minds work. You've got system one, which is fast and reflexive. It's your gut instinct. It looks at a problem, finds a similar one it solved before, and instantly picks a cheap, easy solution. And then you have system two. This is your slow, deep, deliberate thinking. It uses reinforcement learning to really chew on a complex, new problem and figure out the absolute best tool and strategy. This is the governance layer that current AIs are completely missing. So instead of having one giant AI brain trying to be an expert in everything, Atlas works like a really smart traffic cop or a project manager. Here's how it works. A small, efficient router model intercepts the query. Then it looks at its team of specialist models, picks the best one for that specific job, and then hands it the exact right tool to get it done.
And the really cool part is that it learns. Over time, it figures out these perfect professional pairings. So it learns, oh, for coding or math, I should grab the DeepSeek model and give it a Python environment. Or for fact-checking, I know that if I pair Llama 3 with a good search API, I can hit 99% accuracy. It's not just guessing anymore. It's building a playbook of what works. Which brings us to the real verdict here, the main takeaway from all this research. For so long, the whole industry has been obsessed with one idea: scale. Just build bigger and bigger models. But what Atlas proves, pretty definitively, is that the future isn't just about a bigger brain. It's about a smarter architecture.
And look, the numbers don't lie. The results are just incredible. By using this clever setup, a tiny little router managing a team of small, cheap, open-source models, they saw reasoning capacity jump by 30 to 35%. That's not just a little better. That's crushing what the big, expensive, single models can do.
And this is the real conceptual jump we need to make. See, a standard LLM is basically a giant memorization machine. It's trained to know answers. But Atlas is different. It learns what's called a policy of investigation. It doesn't memorize answers. It learns how to find them. And that's the secret sauce. That's why it can tackle totally new problems it's never seen before. It has a method, not just a memory.
This really is the paradigm shift for AI. The old way, the way we've been doing it, is all about just making the model bigger, cramming more and more intelligence into the weights and just waiting for GPT-6. The new way, the Atlas way, says, no, let's be smarter. Let's move the intelligence up a level into a governance layer that knows how to manage a team of specialists. So what this all leads to is a really powerful conclusion for anyone building with this stuff. The game isn't about writing the perfect prompt for one giant AI anymore. The future is about becoming an orchestrator. It's about designing and building systems that can intelligently manage all these different models and tools. I mean, what this research really proves is that you can achieve incredible results with consumer-grade hardware as long as you have a smarter design. It totally changes the game. So the real question for all of us is, now that we know the path forward isn't just about scale, are we ready to start building these smarter, more elegant systems?